Okay, here's the first video for section 4 of your trigonometry book. Chapter 1 is using the definitions of trigonometric functions. We're going to start putting in some of the identities that we're going to be using later in the book, later in the semester, starting with this idea of a reciprocal identity. So from our last section, if we went back and looked it up, we had that sine was always equal to our y value over our r value, and cosecant was always equal to the r value over the y value. In other words, sine and cosecant are reciprocals. And it doesn't matter what angle we're working with. The sine of that angle is the reciprocal of the cosecant of that angle. And that could be written either way. Okay, the cosecant is 1 over the sine, and the sine is 1 over the cosecant. And that would go for any angle theta. Doesn't matter what the value is, the cosecant and the sine will be reciprocals. Now in reality, there are actually 3 of these identities. Now we just stated number 1, and that is that the cosecant of any angle is 1 over the sine. Keep in mind that there are actually 2 forms of that identity. We could also write that as the sine is 1 over the cosecant, but we're not going to use that one nearly as often as we will the blue one, the first one. There's actually 3 of these because our 3 basic identities each have an associated reciprocal identity. We have that the secant of any angle is the reciprocal of its cosine. So secant is always equal to 1 over cosine. And again, that has a second form. It could also be written as the cosine is 1 over the secant. But we're not going to use that nearly as often as we are the blue version there. And then finally, this is the one we'll use the least often. The cotangent is the reciprocal of the tangent. And again, that has a second form as well. You could also write that as the tangent is 1 over the cotangent. Okay, so we have these 3 identities, and we are going to make use of them in a couple of really easy problems. So here we go. Find each function value. Find the cosine of theta given that the secant of theta is 5/3. Well, since the cosine is the reciprocal of the secant, the cosine would be the reciprocal of 5/3, or 3/5. It's that simple. They're reciprocals. Just flip the fraction. But keep in mind that you might have to simplify. There are a couple of things that can come up that could cause us a problem. So for instance, find the sine given that the cosecant is negative root 12 over 2. Well, the sine is the reciprocal of the cosecant. So that means that the sine of theta would still be negative, but it would be negative 2 over the square root of 12. Now we have discussed that we're not allowed to leave root 12 in the denominator. So we would need to start by rationalizing the denominator, multiplying the bottom and the top by the square root of 12, which would give us negative 2 root 12 over 12. Now, root 12 is not simplified. Root 12 can be written as root 4 root 3 or 2 root 3. So that is negative 2 times 2 root 3 over 12, which is negative 4 root 3 over 12. Okay, and then those are both divisible by 4. So then we have to reduce the fraction. divide the bottom and the top by 4, and we get negative root 3 over 3. So as you can see, there could be some algebra in there that we have to do to simplify our answer. But what it boils down to is these are going to be reciprocals. We're just going to flip the fraction and simplify what's left. So let's do a couple more. Here are examples 3 and 4, and then we'll end this video and start the next piece on a separate video. Find the tangent, given that the cotangent is 4. Well, the tangent is the reciprocal of the cotangent. So in this case, well, cotangent is 4 over 1, so the tangent is 1 over 4. Find the secant, given that the cosecant, or cosine, sorry, is negative 2 over root 20. Well, secant is the reciprocal of cosine, so we would flip that over to root 20 over negative 2, and the negative can go at the top or the bottom, it doesn't matter. Well, root 20 is reducible. It reduces to 2 root 5. And then we can divide the bottom and the top by 2. I wish my pen was working exactly right. So we have negative 2 root 5 divided by 2. Bottom and the top are both divisible by 2, so we reduce. And we get our final answer, which is negative root 5. Simple stuff, simple stuff. Let's go on to the next thing. That'll do it for the first video for section 4.